Estimation of ash in food is another important food analysis that is done for a variety of reasons. Normally, it is expressed in terms of total ash. We initially do the total ash contents, and then, if needed, further analysis are done. So, total ash, normally we used a silica dish. These are special dishes that are used in determination of ash because they can withstand higher temperatures. And normally, the food sample is added to the silica dish. In some cases, when there is very high moisture content food, we might need to pre-dry the sample before we add this to the silica dish for further burning. As we discussed earlier, that ash is whatever is left after burning. So the burning operation is done here for the ash analysis. Once this silica dish have food sample in it, it is placed in the muffle furnace. Muffle furnace are a kind of furnace that goes to a high temperature like 500 to 600 degrees C, and the food is ignited at this temperature overnight until the food is left in the form of grayish ash. So this grayish ash would not contain any other organic matter, it's all ash. As we discussed in case of moisture analysis as well, once we take the silica dish from the muffle furnace, we cannot weigh it directly because there are chances that there would be moisture condensing from the environment onto the dish, adding to the weight, a slight weight to the dish. So that might have some error in the food analysis. So rather than directly weighing this dish, we would place this silica dish into the desiccator, and we normally place it there for some time unless it achieves the normal room temperature. Once we take this out from the desiccator, then this is weighed and we calculate the difference, like the initial weight of the food deducted the final weight, that is the weight of the ash. So this is how we can calculate. This is the formula for measuring the ash on dry basis. As I said that ash can be measured on dry basis as well as on wet basis. This formula is basically dry basis percentage ash. So we calculate the weight after ashing and the tare weight of crucible. So tare weight of crucible would mean the weight of the food that was present in the crucible. It is divided by the original weight of the sample and dry matter coefficient multiplied by 100. So that would give you the value for percentage ash on the dry basis. This dry matter coefficient is basically the moisture content. It is basically the dry weight of food divided by 100. So if we suppose have 87% dry weight for a food divided by 100, so that would be 0.87 dry matter coefficient. So this dry matter coefficient has to be measured for every food. Another method of measuring the ash content is wet ashing. Why we use this method is because not in every case we can use the muffle furnace and heat the sample at a very high temperature, because there would be chance of volatilization, or there might be change in chemistry of the food, so that we lose most of the other or ash contents as well during this high temperature. So what we do here is we use certain oxidizing agents and acids. So they would dissolve the ash content within these solvents. The method here again is we use Erlenmeyer flask and we add the food sample in this flask. Again, if we need, we can pre-dry the sample. and then add this to the earthenware flask. We add sulfuric acid, 3 milliliter and 5 milliliter of nitric acid. So these are the strong acids. They would burn all the organic matter. And as in other analysis, we have to use a blank sample as well. The blank sample is a sample in which we are not adding food, but we are adding all the other reagents, and we are treating this the similar way as we are treating the flask with food sample. Then this is heated at 200 degrees C. As you see, we are not heating at 500 degrees C. The heating temperature is not that high. So we heat this solution at 200 degrees C. Then we add nitric acid again and boil the sample. After boiling, we bring it down to the lower temperature, we cool it, then we add water, ultra pure water into this flask. Why we add ultra pure water? Because we don't want to add more minerals that are there in the normal water. Once we have done this step, then we can have two more types of analysis performed if needed. That is water soluble ash. We measure the ash that is soluble in water. So we filter everything. So whatever is solubilized in water, that is calculated as water soluble ash. And this water soluble ash gives us information about fruits and vegetable content in some of the products like jams, jellies, or other preserves. Because most of the minerals from these fruits and vegetables, they are soluble in water. Another aspect of this analysis can be, we can measure the acid soluble ash as well. Acid soluble ash, on the other hand, gives us information about impurities in the food sample, like sand and talc. Sometimes we can add these things as adulterant in foods. So just in order to know if there are any foreign elements present within a food sample, we do this acid soluble ash contents. So normally this was all about ash analysis, where we perform the initial analysis, we do the total ash contents, and if needed, we do the water soluble ash as well as acid soluble ash.